Press the bell icon on the YouTube app and never miss another update.
Hi students, in the previous session we have discussed on graphs starting from the straight line. We reached up to ellipse hyperbola and special case as rectangular hyperbola and different types of shapes or curves what we got. But today is an important video session because most or otherwise 100% formulae you have learnt in high school. All these require in physics. I am not discussing better I say it is we are listing out the formulae which we required to understand the behind physics of them. Many physical quantities or bodies in 2 dimension or 3 dimension starting from circle, ellipse or even cone, or even in case of 3-dimensional bodies like sphere, cylinder. In such cases, we have to know, we do some measurements using physical instruments or physics instruments like vernier calipers, screw gauge and all, even meter scale, weighing machine. So the important here is measuring the data, maybe the length or height or breadth or thickness or radius or eccentricity in case of ellipse. We measure something. We can get some quantity regarding that. The major quantities in 2 dimension we are going to see is about with the length or data measured, we have to see 2 things, that is area, surface area of the shape we got, and second one is the circumference of that. Second, in case of solid bodies, the 2 things important are surface area of the shape, body and volume. Let us list out them because it seems to be simple and known, but we cannot neglect. Small things will make us to find much difficulty in the entrance because once the formula were not recalled properly and we cannot get the marks. Therefore, maybe simple things, but listing and keeping at a point is most important, required mathematical tools for physics in the bridge course. So let us start with circle, which we have discussed in the previous session. If we have a circle, so as it is a 2-dimensional body, a circle is a shape having equal variations from the center distance. You know the radius is r. With this we measure 2 things. One, if you take surface area, can be measured as a pi r square if you know the radius. And also you have studied d is the diameter, which we called as a 2 times that of radius. Even area, if they given in terms of that pi d square by 4 and know the value of pi is 22 by 7 is standard one. So these 2 things, if you know the radius or diameter, you must be able to get the surface area. And the second regarding this is a circumference. Circumference is 2 pi r. ಸುತ್ತಳತೆ ಅಂತ ಕನ್ನಡದಲ್ಲಿ ಕರೀತೇವೆ. Circumference, or it may be 2r as a pi d, where d is a diameter considered. The 2 relations are even and often we are using in physics in many chapters. Coming to the second one is a square shape. You know, square, immediately in your mind starts working regarding the 4 sides, bounded by 4 sides. Each side is equal in magnitude and diagonals are also equal in magnitude, intersection of common point. So, but the 2 things what again, area if I called, surface area A, each side is same, A square gives you the surface area of the square. If you want the circumference of that square, each side is A plus A plus A plus A, so let it be equal to 4A. May be simple, but I am only making you to recall and to be at one slot, in one page we have to have all formulas. What we required, I told in the beginning class for you, is known to you, but what we want for physics, what are the things from maths we need, or what are the things what we studied in high school is need for physics in the PUC section, which make physics easy to understand. So please, keeping in mind, I am taking all this. Even you take rectangle, once you are thinking about a rectangular shape, two opposite sides are of equal in length. One we are calling as a length and breadth anyway. So in that case, if you take the area, length into breadth gives you the area of the rectangle. And if you want circumference, L plus L is 2L, B plus B is 2B. Therefore, we write 2 into L plus B is the formula for rectangle. Circumference of the rectangle and surface area of the rectangle. These three, we have come across 3 points. Remember, circle, square and the rectangle. Now I come to the different one. I hope you are followed. These are not to be in the book or in the sheet. It should be in our mind. Whenever call in physics, you must be able to say immediately, better I am saying these formulas should be at the tip of our tongue. Immediately we must be able to answer what they are when situation arises. So let us another fourth one where we are concentrating more on area, surface area rather than circumferences. Both requirement I have taken circle, square and rectangle. Now you are discussed one ellipse. Surface area of the ellipse, you know the shape, major axis and minor axis. If it is A and this is B, semi-major axis and semi-minor axis, you are able to get the surface area of the ellipse. Let another is triangle. Surface area of the triangle. Suppose if we have a triangle, which we are calling it as a base and this as a height. This as height. Half into base into height help us to measure the area of the triangle. Sixth one, let us come to parallelogram. Surface area. When I am talking about parallelogram, particularly for this, two opposite sides are of equal length. Tilted, slightly tilted rectangle is a parallelogram. These two sides are equal. But when you see this, if I diagonally join them, you are seeing the triangle 1 and triangle 2. Area of the triangle you have understood. Now what my question is, here how to find is nothing but drop the perpendicular. This is the diagonal. I am saying this perpendicular which I am drawing is the height and this is called as a base. So base into height gives you the area of the parallelogram. Coming to the 7, as a trapezium, the important these are all. Trapezium case is how means they are unequal size too. So maybe of this form. This is of length B, this is of length L, but there is a perpendicular distance between the two lines, which I am calling it as a H. Perpendicular distance between the two lines, parallel lines. The surface area is half into sum of the two parallel side length L plus B. Please listen my words. Sum of parallel sides length and so L and B, sum of length of parallel sides into perpendicular distance between them is H. This gives you the area of the trapezium. These are the important shapes: ellipse, triangle, parallelogram and trapezium. The area measurement is helping us to study physics better. So all those quantities are two dimensions we have taken on a plane: circle, square, rectangle, ellipse, triangle, parallelogram, trapezium. These for area only. For the previous three I showed you the circumference as good as the surface area formula. Let me go to the three-dimensional bodies like sphere, cylinder and cone, like that. So we are taking some important shapes which are commonly used in physics. For most importantly is about the sphere. So coming to the sphere. So the sphere, we have the shape like this. Three-dimensional bodies now we are imagining. It is also measured by the radius r. In case of three-dimensional bodies, two things importantly required in physics is about surface area A is equal to, you are knowing, 4 pi r square, where r is the radius and pi is 22/7 standard value, and volume of sphere V is equal to 4/3 pi r cube is 1. Second, importantly, you have learnt is about the cylinder. The two things again, area. When I talk about a cylinder, this shape has two circular shape base and top and height h. This may have the radius r about its axis. Suppose you want area of base, area of base only. That is nothing but I can say it is r pi r square. So I can take about area of the curved surface. This area of the curved surface. If I open this, you will get a sheet, plain sheet. It is a cylindrical structure. When I open that, it becomes a sheet. So circumference is converted to one side. So this is nothing but is becoming 2 pi r, where r is a radius, and other one is h. So you can write it as 2 pi r h. Thereby the area total of the cylinder, if you required, sum of the two, pi r square twice. Why multiplied by 2? Because top and bottom two surfaces are there. Plus 2 pi r into h. This gives you the total area, base area and area of the curved surface. Suppose if you want volume V, base area into height, base area is pi r square into height gives you this. Another that is coming is about this disk. When I am talking about the disk, I am morely concentrating on the volume. Because the disk is like a coin, thickness is very less, but resembles with a cylinder having the area. If this is the thickness is a T and R is its radius. If this is the thickness of the disk, then volume is again pi r square into height, similar to that of the cylinder. Compressed cylinder, if you compress it, you will get a thick sheet, very thin sheet, which is maybe having definite thickness measurable with a circular shape base and bottom and top. So where we get this as a pi r square into T. This is about the disk concern. If I come to the ring, you may understand it is a form like this. Even I go volume only here. V is equal to, when I open this, it become a wire like thin wire you bent in the form of a circle. So it has a length that is a 2 pi r, no doubt. If r is the radius of the circle, 2 pi r. Measuring volume relied on its area of cross section. If I cut this wire, you will get this area. This circular area which we are seeing is called as a cross sectional area. If it is A, cross section area, that gives you the volume of the ring. So importantly, knowing this, I summarized here. Let us see the remaining. I hope you are followed about the sphere, cylinder, disc and ring. Let us come to the others. So in case of a cube, we have taken rectangle in 3 dimension, we are calling as a cube. In case of cube, all the faces are of same size, having 6 faces. Each side is measured to be have the same value. Then when come to surface area of each face, surface area of each face, if I called 1, it is A square. If I consider the one face, just one face area, that comes to be A square. How many faces are there? There are 6. This is 1, 2, 3, 4, 5 and behind 1 is 6. Therefore, total surface area total is 6A square. And similarly coming to volume V is A cube. All these sides A into A. Then coming to the cuboid, cuboid have different three sides. So it is a length, breadth and height. Even six faces, two opposite faces, front and back, top and bottom, side these two. For example, if you take these two sides are of same area, or if you consider these two are of same area, therefore total area of this cuboid surface area, if you want, this is 2 into, because there are two such faces, L into B gives base, similarly B into H gives this, and H into L gives you the other one. So 2 into LB plus BH plus BH plus HL gives you the total six faces area. Volume concerned, V is equal to L into B into H. So coming to the seventh one is a cone, the most important one. You have learned in high school. All these formulas are known, they are not new, but our aim is to know what you know for the physics concerned in the PUC. If this is the base radius and it is called as a base and base area, it is a height slants curved surface. Let's start with here. Area of base, this area of base is nothing but pi r square. Area of curved surface, this surface, area of curved surface, which is in the form of a cone, this is pi r into slant length. Total area, if you want, of this cone, pi r square plus pi rs gives you the total surface area of the cone. Where S, how you determine is, you can use the Pythagoras theorem, because this is 90 degree, this is a slant height, vertical height, and R. You can write knowing H and R. H square plus R square. Volume, you studied in case of high school, shown you maybe, a cylinder, pi r square H cut into three pieces. If you join them three, you will get the cylinder. Therefore, we write pi r square into H. So again, we have taken three here. One is cube, surface area and volume, cuboid and cone. So these are the some standard shapes, maybe in 2 dimension or 3 dimension. We have taken the standard relations. I told you they all must be at our tip of tongues, not in the paper. Let us go to the other parts. So in case of physics, at 2 points majorly, we want certain distances in case of a square or cube, or in case of a triangle, the centroid to the any piece of the triangle, what the distances, how they related, how to estimate. Majorly in many problems in entrance, it helps you to solve easily the question. So let us see those 3 important relations. Some important. Number 1, I taken the square. Please listen. If you remembering here onwards, it is more easy because I told you if you are interested in entrance, 1 minute, one question I have to answer. You are not having time to derive and get the formula and substitute and answer. You must have to know better this. Each side is A in case of a square. So if you want the diagonal length, if I named as A, B, C, D, what is this diagonal length is nothing but, or it may be BD. Use the Pythagoras theorem, this is 90 degree. A square plus A square gives you 2A square. But you want AC or BD, square root of this gives you root 2 into A. That means this length, total AB, AC I can write as a root 2A. Now your opposite diagonal, if you draw the intersection point is this center of the square. If you draw a vertical, it is exactly this distance is becoming A by 2. Or here if you take this also become A by 2. The importance is this either AO or BO or DO or CO length if you required. AO or BO or CO or DO is nothing but AC by 2. What you got AC is root 2A by 2. This can be written as root 2A by root 2 into root 2. Therefore, A by root 2. Now this I am saying this length which I am writing as AO become A by root 2. This center to any corner of the square or length of the diagonal are very important terms in substitution in physics requires that as far the square is concerned. Let us similarly I am taking the cube. This is a cube. This corner to this corner. I want center of the cube. Center of the cube to any corner of a cube, what the distance is necessary. If I join this, and similarly if you take another one, front to the back, they meet about a point. This is the center O. If I call it as AB and this may be C, I tell you how to get this value AO. It is not in the plane. Now this is the top surface. The diagonal is going like that. Back point A to front corner B. Similarly, if I take like that, you will get the point center. Center of the cube distance from any corner of the cube is same. So to get that, I draw one here. If I call it as D, it is on the surface like a square because all sides are of same length. What is this AD is a diagonal. Already AD diagonal length we got it as a root 2A. This is root 2A known to us and this is already A. This value is A. And what happened? Again, this is a right angle here, C. It appears to be like this. Now joining line. If I show this in the 2 dimension, this is AD for reference. And this will be B and joining like in 2 dimension. 3 dimension if it is a plane and this is a plane. Joining these ends. These two are perpendicular to each other. So it is root 2A and it is A. What is this AB is? So if you want AB is nothing but square root of Pythagoras theorem can be applied root 2A whole square plus A square This become 2a square plus a square is 3a square, or it is root 3 into a. Fine, we got this answer. AB is equal to root 3a. An important tool required, we got it. Suppose you want AO or BO. Now students, you are understood it is a 50% center of that diagonal. That means root 3 by 2a. That means I can write this AB as a whole. AB as a whole is root 3a. Suppose I want AO or BO as a root 3a by 2. These relations must be very important and quick in your mind to recapitulate to get the solutions to the problems. So therefore, I shown this in case of a square and in case of a cube, center of the cube and center of a square to any corner distance length or diagonal lengths. Let us come to the triangle case. Third one, in case of a triangle, circumcenter. This A, B and C. Each side is of length L. But if you join all the apices of the triangle are lying on the circumference of a circle of radius r, if radius is r and this is the center. Many times we lock in the problems in physics because they are not giving what we required. That's the secret of entrances. If you want r, they are not giving r, they give L. If you want L, they are not giving L, they are giving R. We have to find L. If they given L, we necessarily have to find sometimes R. If the given data is no problem. If they are not given in terms of others, we have to find the relation between L and R. So you know it is a circumcenter 360 degree and this will be 120 degree and this total is 60 degree. And this bisect, therefore this is 30 degree. If I drop a normal at the point as D, BD is nothing but L by 2, 50% of the length, bisect this chord. Now use your trigonometric rule. You have learned, otherwise we will come to, but known well that you are better than me, better in trigonometry. It is a 30 degree. This is R. This what I considered is L by 2. This I enlarged and shown here separately, this part BO and D. BO and D. Our aim is to get L, total length, because this also L by 2. Total length is L. What you want is L. Take it in the numerator. R is known, denominator. This side in the right angle triangle, because vertical this is 90 degree and this is the angle, you are calling it as opposite side, hypotenuse, and it is adjacent side. Adjacent side by hypotenuse you defined as cos theta. That I am writing here cos 30 degree, directly cos 30, and that is equal to L by 2 by R. But I hope you are also knowing what is the cos 30 value is root 3 by 2. Now our job is over. L by 2R equal to root 3 by 2. 2 to get cancelled. Length is equal to root 3R. or R is equal to L by root 3. So this important relations required. If they give R, you can find L, or if they given L, you find R. If necessarily in solutions necessary, use that relation. These three relations, center to any corner of this square, center to any corner of a cube, and relation between the length of the triangle to the radius of the circle, distance circumcenter to the any apiece of the triangle, the relation is R equal to L by root 3 or L is equal to root 3R. These three important relations even and often we use in physics. I hope you are understood. Mute it, understand and clarify your doubts. So I am coming to another important concept related to the triangle, which also necessary in further when we go to the trigonometry, properties of triangle. Again I am saying you all studied this. I am only summarizing and what necessary for physics I am giving here. Let us consider a triangle. Angle A, angle B, angle C. This is of side length A, or if you are confusing, I can write this A, B, or C, and points may be, a piece can be written as P, Q, R. So you are seeing the three angles A, B, and C. Quite opposite to A, B opposite is B, C opposite is the C, small c. This is a capital C taken. In case of triangles, you have learnt many things, because in a triangle, it is to be formed, then one property you know, the ratio of the side to the sine of the opposite angle is always a constant. That means A into sine of A is equal to B into divided by sine of B equal to, if I take C, side C by sine angle C or sine, corresponding the ratios, or I can say A is proportional to sine A, that is A is proportional to sine A, or B is proportional to sine B, or C is proportional to sine C, is always we can write in the form. It is a constant. Proportionality if I remove and I bring a constant and write in that ratio. This is always a constant which can use to get the some solutions. And second, you remember here, these ABC and angles are related equations you have learnt. Suppose if you want A square, B square plus C square minus 2AB into sine BC into sine A. Similarly, B square if you take C square plus A square minus 2CA into sine B. Or if you want C square, A square plus B square minus 2AB into sine of C. This relation also you have come across in the high school. I hope ABC are the side lengths. This is the magnitude A and this is the magnitude B and this is the magnitude C. And ABC are the angles. You learnt these. I hope these two relations you are followed correctly. Let us see the other things. First note down this. And before concluding, I may come to another is about area of this. Another way of finding area of triangle. So half, if you take AB, then of sine C, this is area, directly I am writing. So or half BC into sine A, or half AC into sine B. Can calculate the area also. See, there is some permutation and combination are visible in this. ABC, A square, B square plus C square. When you take A, that comes in the sine function, B square plus C square minus 2BC sine A. If it is B, other two, C square, A square, again B. And C square, A square plus B square with C. Even in area measurement, half into, if you take the AB and opposite that of sine C, enclosing that, AB of C comes. If you take BC of sine A, and again in case of AC, if you take A and C, in between is sine B, that help you to measure the area. And in case of one I give you, in case of isosceles triangle, please listen to me, I am not writing all, only recalling, this idea is necessary. Isosceles triangle in which the two sides are of equal length, made by angle theta. Then if you want to know the distance x, third side, I show you this with the help of your trigonometric knowledge. This is 90 and this divides as x by 2. And this angle divides as theta by 2. Our job is over and you can apply the trigonometry and get the answer. So even in this case you want opposite side, angle opposite. This is 90 adjacent, this is hypotenuse. What is the sine theta by 2? Sine of angle you are writing? That is nothing but x by 2, this x by 2 upon L. What is our requirement is x, length of the third side, 2L into sine of theta by 2. An important relation immediately can get. In case of isosceles triangle, the two sides of equal length and they are bound by an angle theta, then the length of the third side is equal to 2L into sine of theta by 2. Double the length, theta half with sine. So this I given you. I am now coming to the specific case of many solutions in physics, in derivations of various formulas. We are using concept of similar triangles. Similar triangles, and you studied the properties 3. SQ property, SAS property and AA similar property. So all these 3 I summarize here. Before that, I hope you are followed related to the property of a triangle, measurement of area, measurement of sides with angles or the ratios concerned. Thank you. Now let us go to that one. Similar triangle, concept of similar triangles. Have the same shape. The two triangles may have the same shape. Let us take the two triangles ABC and another triangle PQR. Seems to be similar to us, but size different. I take for this 4 centimeter, it is 8 centimeter, or it may be 10 centimeter for convenience to understand this. And here I take 6 and it may be 12 and 15. Similar triangles possible. The ratio of corresponding sides should have the same. Sides of the triangle, if you take AB and PQ, the ratio would be same. That means AB, the first corresponding ratio is AB by PQ. This BC, corresponding side for this is QR, is equal to AC by PR. must be same. It is a constant. It takes a definite value. To make you convenient, I taken this example. For example, you take 8 by 12 here is equal to 10 by 15 because BC by QR. Similarly, AC 4 by 6. What is this? You take 4 2s are 4 3s are. It is a 2 by 3. A constant value is coming for any ratio. So it is 2 by 3 again. 5 2s are 5 3s are 2 by 3. 2 2s are 2 3s are 2 by 3. And another logic I show you. Take these two. What is the project? 15 into 8 is 120. Product of these two, 120. Same. These two, let us take in between these two, is a 10 into 6 is 60. Take these two, 15 into 4 is 60. See beauty of maths. Or take between these two. To say similar triangles, 8 into 6 is 48, 12 into 4 is 48. Any pair, if you take that ratio, that similarly proportionately remains same. And further, these measured angles must be same. B to Q, angle of B must be equal to angle Q, and angle A must be equal to angle P, and here angle this C must be equal to this. So then we say two triangles are same because here three sides are proportionately matched. This you called it as a S property, and sometimes you are called as a S cube property of the similarity of the triangle. Two triangles are said to be similar. The corresponding ratios of the triangle should be constant. Proportionately they should match. The side matching, that is S cube property, you are called it as. Now coming to the second one as a SAS property. I am coming to this. Let us remove this, that one property by which we can compare the two triangles. And now coming to the other one. For SAS property, let us consider this. This is the angle A, 9 and 3, 12 and 4 for reference. This length is 12, this length is 4, this is 9 and this is 3. A, B, C and D, E. Seems to be a single triangle, but there are two triangles I have taken. So if I split this, one triangle you are getting here is A. This length is 9, ADE. This is 12. Another triangle I am taking. BC, A, angle is A, 9 plus 3 it is 12, but 12 plus 4 is 16. In case of SAS property, side angle side property are same. Here you are observed this angle A is common for both. That in SAS you are seen one angle same. And as previously we have taken side ratios, if you take AD by AB must be equal to AE by AC. Right? Now your expertise become AD by AB is equal to AE by AC. For example, what we taken here is 9 by 12 must be equal to 9 by 12 is 12 by 16, 3, 4, 3, 4. It appears to be common as a 3 by 4. It remains a constant. Then we say two sides are of same. Two sides same, angle same, then two triangles are said to be similar triangles. So even you multiply these two, 69s are 144. You multiply these two, 12 12s are 144. See the beautiness in that. So there come to be under SAS property also we can say the two triangles are similar triangles. Let come to the another one, and with that I conclude the class. This your AAS property, angle side property. AA similar property. So this is most used in physics. So two triangles now we have. Again, if you measured, this is a straight line and these two lines are intersected. These two angles must be same. These two made common. The two triangles have the same angle. And this is the normal to the line which we have taken. It is 90 degree. Another angle is satisfied. If the two triangles are satisfied and third angle must also be same, that means this angle must agree. Then we say the two triangles are same. Two angles become same, so that third angle becomes same, and the corresponding sides ratio. For example, if A is BC, if you take BC by D, again we go AB by AE becomes same. That's what we say. These three methods employed in high school you have learned, that we use here in physics for many solutions or in derivations of many physical quantities relation. So this is what we have discussed only on the shapes and important formulae, and some substitutions we have taken. With little bit remained with some equation, we will look into the next session tomorrow. Thank you. Don't neglect these. You all learned these. You well versed with relations. Only I recalled you to help to learn physics better.